Good evening, wherever you are. Thank you so much for joining us today. Welcome to our joint webinar. My name is Joyce Joe. I'm a field marketing manager here at Impinj, and I will be moderating today's event. Again, thank you so much for joining us. Datamars is an important gold partner of Impinj, and we are excited to share with you today Datamars' innovative textile ID solution, Impinj's technology, and how RFID can help accelerate your organizations. We have structured today's webinar in a Q&A format. There will be two segments. The first segment will focus on introduction to Datamars, textile ID solution, and Impinj, the benefits and the challenges of using RFID in a textile and laundry tracking environment, and how the textile ID solution can solve for the challenges. Our second segment will focus on Datamars' innovative concept of RFID, combining artificial intelligence and machine learning with RFID to produce superior results. There will also be some exciting demo videos to help you better understand the technology. We also want to make sure that you are kept engaged throughout this webinar. So there will be two live Q&A sessions, one after each segment. So please ask us questions at any time using the question tool in the webinar panel. Next slide, please. So this is what the tool looks like. So feel free to ask the panelists any questions at any time, and we'll make sure to answer them during the live Q&A session. So the entire webinar will be around 90 minutes. There will also be a short survey at the end of the webinar. The short survey will help us improve future events like this one. And the first 10 people who complete the survey will receive a prize. Datamars will also be giving away 5 free licenses of their signature software, CLOUDBURST, the software layer running on Impinj readers and Datamars UHF reading systems designed specifically for the laundry environment. We will share more details about how you can win those free licenses at the end of the event. Okay, so now the exciting part. I would like to introduce you all to today's presenters. Can all the presenters come on camera? So from Datamars, we have Julian Bruce, Textile ID Product and Services Director, Andrea Carbonetti, Senior UHF Product Engineer, and from Impinj, we have Todd Farley, our Vice President of Global Sales, and Jonathan Newkirk, Product Manager. So everybody wave hello. Thank you. Okay, all right, so on to the show. So the first question I have for the panelists, obviously, I have a lot of people here already. So who is Datamars? Julian?
Yeah, hello Joyce. Hello everybody and welcome to this webinar. So yeah, a few words about Datamars to start with. Let's go to next slide. So Datamars is a pretty old and pretty big company considering the business sector we are in. The company has been founded in 1988, and we are almost 2,000 employees working for Datamars. It's divided in 4 business units. 3 of them are dedicated to animal management and animal identification. By animal, we mean both pet and livestock. The 4th business unit is the one that we are interested in for this webinar, which is the textile identification business unit. And we work and we design textile identification solution for the industrial laundry, specifically for the industrial laundry. Next slide, please. So, more in detail about the Textile ID division. The business unit was founded together with Datamars more than 30 years ago, and we actually invented the first laundry chip whose goal was to identify workwear. At this time, that was a low frequency transponder, which then moves into a high frequency, and we are now at our 4th generation of UHF laundry chip, We serve customers in more than 40 countries, and we have over 10,000 RFID reading points installed all around the world. Next slide, please.
All right, well, thank you so much, Julian. 33 years is a long time. In fact, Impinj just celebrated our 20-year anniversary. So Todd, can you introduce the audience to Impinj?
Great, thank you, Joyce, and thank you to the Datamars team as well. So for those that may not know who Impinj is, I wanted to spend just a couple minutes giving you a quick insight into who we are. So if you think about Impinj, what our goal is we want to give a digital life to everyday items. And ultimately in doing that, we want to create boundless IoT. We want to be able to create physical things to have a digital identity and to have everything connected into the cloud so that businesses can transform the way they operate, right? So if I can give a physical item a digital identity and have that connect into business applications, it's amazing the power that that has, whether you start knowing where items are, when they were there, how many, right? And you start doing that. The way we give digital life to everyday items is through what we call RAIN RFID, or what you heard on the previous slide, ultra high frequency RFID, but you'll hear us refer to it as RAIN RFID. And when you think about RAIN RFID, three components that Impinj does. Number one is the actual digital identity, the chip, the endpoint IC. It's about the size of a grain of sand, and that's what gives a digital identity to a physical item when paired with an antenna. Second thing we do is we make what we call reader chips that are connectivity devices that power the chip. So RAIN RFID, it's passive in nature, and it gets its energy, it wakes up when it comes into proximity of a connectivity device. And so those reader chips enable other products to become RAIN readers, handhelds, fixed readers, printers, etc. And then finally, we make purpose-built readers to solve very specific challenges in the industry, and you'll learn and hear more about that throughout this webinar. So if you think about what we do, giving a digital life to physical items. We're a global company. We have operations all over the world. We have partners all over the world who take our technology, build solutions to solve customer challenges. And again, it's all about having information or creating data to solve business problems. And if you go to the next slide, when you think about what this looks like, I talked about this digital identity for a physical item. Our goal is to connect everything, to connect every item, to have this boundless IoT that we enable. When you think about today, where our technology, RAIN, is being used, there's about just north of 20 billion items that are being tagged today. And when you think about, when I say tagged, that means a physical item, a shirt, a textile, right? Laundry, things of that nature, they have a digital identity. About 20 billion of those exist today in the world. When you think about our vision, right, where we want to create this boundless IoT, we want to create this ubiquitous environment where all physical things have a digital identity, we're at the very early stage of what the opportunity is. So 20 billion sounds like a large number, but when you start breaking down where we can go with the technology, it's a wonderful start, but there's still a tremendous amount to go. So our hope is that you learn a tremendous amount in this webinar today, and that you come away understanding how this technology and how Datamars software and their industry expertise can really help you as a customer, as a partner, solve critical business challenges by understanding what you have, where it is, when you last saw it, and really connecting those physical things to the digital world.
Great, thank you so much, Todd. So Julian, you mentioned textile tracking as an important part of Datamars business. So can you tell us about TEXTILE-ID and also which sectors and application field the solution supports?
Yes, so in the next slide, we go a little bit more in the details of the laundry business. And the specific sector, the laundry business, and thus Datamars TEXTILE-ID is active in. First, we have the healthcare business. So that's basically the hospital. And here the kind of assets to be identified are workwear and flat linen for the large majority. Another of our sector is clearly industry. By industry, we mean large manufacturing company like automotive, for example. And here the bulk and most important assets are workwear. A new emerging business, I mean emerging for a few years now, is the identification of private wear in the elderly homes, where RFID definitely helps sorting this private wear and prevent from losing it. And finally, our last sector activity is hospitality. So everything that is related to hotel, for example, where the identification of flat linen at a second level workwear is what we are doing. Talking about assets, part of our activity is also related to identification of mats and mops that we find a little bit everywhere in these different fields. Yeah, next slide, please. Talking about products, we are what we call a complete solution provider, a complete RFID solution provider. That means that we provide all the components to make the RFID reading as accurate, as reliable as possible. The first of the components is the tag, which relies on Impinj IC. We also develop a reading system. Here on this slide, we have the example of two reading systems that are developed specifically for the laundry business, this portal and the tunnel. And finally, we developed this low-level software layer that runs directly on Impinj reader and that we call CloudBurst. The CloudBurst has two goals. The first goal is to remove all the complexity that is related to the RFID technology. And for example, CloudBurst has a set of predefined reading system modes, meaning that for each kind of reading system, we have a predefined mode that will optimize the RFID parameters and optimize the performance of the reading system. So the idea is that the user can really get access in a very plug and play way to this reading system. The second goal of CloudBurst is to ease the interface between the RFID system and the laundry application software. So CloudBurst provides a set of data interface that makes the connection between the RFID and the laundry software as transparent and as plug and play again as possible. For example, and that's where the name is coming from, CloudBurst gives the possibility to upload directly from the reader to the cloud all the RFID information. Next, please.
Thank you so much, Julian. So you mentioned Impinj readers being used as part of the TEXTILE-ID solution. I want to introduce everyone now to Jonathan, who will talk a little bit about Impinj's latest, and I may be biased, but I think greatest product, our R700 reader.
Thanks, Joyce. Yeah, as we heard from Todd and Julian, Impinj also makes just fixed readers, but the one shown here is the Impinj R700. This is our latest reader. We designed this specifically to have industry-leading performance across operations for reading tags, to have industry reliability, so there's no concern about once they're deployed in the field, how long they'll last. And then Impinj has been making fixed readers for almost 15 years, so you get that trust and proven Impinj product quality. And then if you go to the next slide, please. So just to deep dive into that a little bit, the performance comes in terms of the industry-leading sensitivity. So that's the ability for the reader to inventory tags in the field of view, as well as some powerful edge processing. Compared to previous generation readers, the Impinj R700 has 10 times the processing power and additional memory, so that applications such as Datamars CloudBurst application can run directly on Reader. We've also done work to make it easier to develop applications on the Reader, so our partners and end users can go and easily interface with rain data. And then again, our partners like Datamars can go and add their special sauce to really dial in their application for their partners. And then the part that we really do well at is making it really easy and consistent to read tag data. So as well as the industry-leading sensitivity, we spent a lot of time improving the RAIN modem so that we get more tag reads with the R700. Additionally, we've gone in and made a really secure operating system utilizing some industry standard tools so that end partners don't have to worry about a non-secure device on their network. And then just in case the application requires it, the R700 can interface directly with additional peripherals, providing support for additional antennas or external sensors as required by the application.
Okay, well, thank you so much, Jonathan. So now everyone has heard about Datamars, Impinj, and our products. You may wonder, so why should companies use RFID in the textile laundry business? Julian?
Yeah, thank you, Joyce. Let's go to the next slide. Here we listed 4 of the main drivers for laundry to use RFID. There are others, but these are the 4 most important. And the first one is due to the fact that textile are probably the most important asset for the laundry. So there is a need to track and trace this important asset to understand how the textile are used and to try to reduce inventories to reduce the cost of this asset. So that means reducing inventory, and that means preventing loss or potentially theft. A second driver is automation. There is like at home, there is a lot of sorting to do when you do laundry, and by identifying one by one the assets, this sorting can be done automatically. So that's particularly important in the workwear laundry business, but also it's important on the soil side. Because by automating the sorting on the soil side, you manage to reduce the contact between operators and potentially infected textile, and especially in these days of pandemic and corona, this is a pretty important topic. Third driver is customer service. Well, if you are missing the right workwear to the right person, you can block a full production chain. So clearly, RFID help reducing this kind of risk. And finally, fourth driver is definitely sustainability. By using textile in a more efficient way, you can use them longer, and you can also use RFID to help recycling the textile. So as I said, there are more drivers, but the 4 more important are the one listed here.
Great, well, thank you so much, Julian. So Todd, can you talk about some of the successes that Impinj has seen with our customers using Ring RFID to track textile assets?
Yeah, and I think I'll actually just build off of what Julian mentioned. But if I think about customers and I think about problems that customers have, they generally boil down to 3 things if I oversimplify this. Number 1 is I need to control costs, right? So I don't want to have too much, or I don't want to have too little. The second thing we see consistently is I need control. Right? I need to know where they are. I need to know where it was last used. I need to know who used it. I need to know, is it clean? Is it dirty? Is it soiled? So I need control. And then the third thing we see is I need efficiency, right? And efficiency ties into cost, right? Because if in order to get that control, I have to do an incredibly manual process that takes lots of time and lots of people, that's cost. Right? And so if we think about it, the 3 things that we consistently see around the world is focus on efficiency, cost, and control. And when you think about how our joint technology is used to solve those problems, you can really boil it down to a couple things. It's number one is the technology can be used to automate processes to understand how much or how many, right? What do I have? The second thing it can do is where is it, right? Because understanding how much is great, but if it's not in the right places, that can have real impact to your bottom line. So how much, where is it, what is it, right? Because if I have a sheet, but I needed a bedspread, or I needed a pillowcase, or I had this uniform, but I needed that uniform, that's critical information. So how much, where is it, what is it, and then ultimately where it last was. And so if you start thinking about solving those business challenges and using the technology to answer some very basic questions, we've seen a tremendous amount of value brought to customers around the globe, enabling them to run their businesses a lot more efficiently in a much more cost-effective way, and having an immense amount of control about where things are, what they have, and how they use them. So as I mentioned, I would say those are the key things that we've seen around the globe in the textile industry, and frankly in many industries really follow that same thing. But again, I would really focus it on those business problems, because that's why you would want to leverage this type of technology, is to gain those benefits, and then the technology comes alongside to help deliver that.
Thank you so much, Todd. So now that you've all heard the significant benefit that RFID can bring to textile and laundry tracking, I'll bet some of you are probably wondering, so what are some of the challenges of implementing a RFID system in a laundry environment? Andrea, take it away.
Yeah, thank you, Joyce. So, well, as we can see from the picture here, laundry environments are generally, let's say, busy, and we have textiles everywhere, textiles that are waiting into a laundry cart. We have textiles that are moving around in sling bags or hanging conveyors. And if you imagine that every textile as a UHF tag, well, that means that the environment is pretty crowded, and well, one of the biggest benefits of RAIN RFID technology is the ability to read tags in bulk and without line of sight and from a very long distance. Well, this is a huge benefit of this technology, but sometimes this may become a drawback, because if we want to have a system that precisely identify a bag or a stack of textiles in a specific place, then this becomes difficult, and sometimes it's easy to end up having some, well, what we call the stray reads, so unwanted readings coming from the surrounding environment that the reader is able to pick up and misassignments, so that those tags that should not be supposed there, suddenly they're assigned to the stack I'm actually reading. So if we look at the next slide, up until now, the way we and the market tried to solve this issue was coming up with shielding structures. Usually these are metallic structures, bulky structures, trying to contain the electromagnetic field generated by the reader and the antennas, so that stray reads cannot be physically picked up, because the signal doesn't come out of this shielding structure. Another possibility is to turn the knobs and set some thresholds on reader parameters, such as transmitting power or reader sensitivity, trying to limit the amount of tags we see, or how far we can pick up a tag from. But as many of you know, this has a limit, because you know, especially if items are moving, the tag that you're not picking up, suddenly you pick it up because it starts moving and the power reflected back to the reader suddenly increases. And so these approaches have their own limits, and at the laundry side, this becomes a limit to the flexibility of the RFID system in adapting to these environments, and ultimately slows down the operation of the laundry.
Okay, well, thank you so much, Andrea. So as you can all see, we're moving along quite quickly here with the webinar with a lot of really good information. If you have questions, please ask us using the tool in the webinar panel box, as you see on the slide. And again, if we can't get to your questions during the webinar, we can always email you after the event. So we do have a couple of live questions coming in. The first question, I think, Andrea, you're probably the best person to take this one. So what are some of the important things to consider when deploying RFID in a laundry environment?
Well, there are multiple aspects to consider. Well, an RFID system in a laundry is made by different components. For sure, we have the tag. So having a good quality tag is very important because, for example, if we need to read textiles in bulk, poor quality tags easily get detuned and the performance suddenly drops, and so we cannot read them easily anymore. Another important component is the antennas. Antennas are not all the same, so it's not just okay, I pick up that antenna off the shelf and it will work, but selecting the proper antenna to the proper use case is an important point. Readers, we talk about Impinj readers. All our reading systems are powered by Impinj readers because the ability of the reader to pick up, quickly read all the tags and have a great sensitivity are two of the most important points, because that's basically what allows us to read even the weakest tag. And on the other side, something that should not be underestimated is the software, because implementing an RFID reader is not just, okay, buy the components and put them there, but there are parameters, there might be automation involved, and all these configuration needs to be done at the software layer. And on the other side, it is important to be able to send these rain data to the laundry management software or any ERP, and here again the problem is selecting a solution that gives you the right data formats, protocol, and interfaces, so that we have a seamless integration and data flow from the RFID system to the laundry software.
Thank you, Andrea. Great answer. So I think the next question you can probably take as well, since you mentioned this earlier in your presentation. Next live question is the problem of stray reads specific to laundry applications?
Yeah, well, as I said before, in the laundry environment, the stray read issue is probably the biggest issue we have, and as we'll see in the presentation afterwards, there are different approaches to limit stray reads and filter out stray reads. So as I said before, and this is still true sometimes, setting reader parameters, thresholds, or coming up with some shielding structure is still something that is required sometimes. While let's say the new way to solve this issue is by analyzing the data the reader can provide us, and with some software algorithms filter them out so that the system is much more flexible and also does not limit the laundry environment and processes.
Okay, thank you so much, Andrea. And keep those great questions coming using this tool, the question tool, and we'll make sure our panelists can address your questions. So now we're going to move on to the second segment of today's webinar. So earlier you heard about the challenges of implementing RFID solution in the laundry environment. Well, Datamars has developed this innovative concept called RFAID. I love the name RFAID, by basically combining artificial intelligence with machine learning with RFID. So Julian, do you want to tell us about RFAID?
Sure, thank you, Joyce. Well, the idea leverage on the fact that Impinj reader deliver an impressive amount of data at a very high reading rate. So when I talk about data, that's for sure the EPC code, so the code of the tag, but that's also the RSSI, the code phase, the date stamp, the number of time a given tag has been read. And by looking closely at all this data, we started to realize that there were a pattern that would allow us to make the difference between the so-called stray read Andrea has just been talking about and that we want to filter, and the good read. Of course, looking at the data manually would be pretty difficult. So we had the idea of feeding this data to a machine learning algorithm and to ask the machine learning algorithm to do this classification. Basically, we use machine learning to find data pattern that would differentiate a stray read from a good read. And we use machine learning as a classifier. So we classify stray read and we classify good read. To give you a little bit more an idea of what we are doing, we prepared a small 2-minute video that present the concept. Ayana, if you can launch it, it's probably the right moment to go through.
For the first time in textile identification, artificial intelligence powers RFID systems. This Datamars breakthrough technology, result of 2 years of research and development, uses neural networks to recognize the right tags and filter stray reads with an unprecedented level of accuracy, identifying moving textiles without interrupting the workflow and correctly assigning tags to physical items, even in bulk. Until now, the constraint of stray reads, false positive tags detected accidentally by the reader, represented one of the biggest limits to automated textile identification, and it has mainly been addressed containing the reading area, with solutions based on mechanical shielding structures and manually setting thresholds on reader parameters. But this approach limits the flexibility of the RFID system and slows down operations. Thanks to the machine learning algorithms leveraging a specifically developed neural network, the system now exploits the information extracted from the RFID tag readings to classify each tag. In this way, instead of trying to avoid stray reads at all costs, the system is able to recognize and discard them by itself without being explicitly programmed. In addition, the good tags are correctly associated to the proper item, even if they are in bulk and in motion. The greater the amount of data, the more precise the neural network can become, easily adapting to multiple environments, use cases, and laundry evolutions. Bring identification to the next level with RFAID.
Okay, that was a great video. So Julian, you mentioned about machine learning quite a bit in this RFID technology. So Andrea, can you tell us a little bit more about how machine learning and how it relates to RFID, or how does it apply to RFID?
Yeah. Sure. So, well, for those who are not familiar with artificial intelligence and specifically machine learning, with machine learning, we identify a specific branch of the artificial intelligence, which is the most common term. But let's say the ability of the machine learning is that without programming an algorithm, so without being explicitly programmed, we can feed this system with a huge amount of data, the so-called training data sets, so that the algorithm learns by itself how to recognize some common patterns, like Julian mentioned before, to come up with a neural network that is then able to make a decision on whether a tag is a stray read or a good one. So we have a very simple example to let you understand how the training and classification works in the next slide. So if I show my 2-year-old daughter bananas and apples, and I show them, yeah, there are some little differences between bananas and because one is a little bit more yellowish, one is a little bit bigger, smaller, and these are apple instead. And you see that the difference between bananas and apples is pretty evident. So because the apple has a more round shape, has a leaf on top, and the color is red instead of yellow. So next time when I go to the supermarket with my daughter, she is walking around and then she looks at the apples and then she screams, "Oh, look at, that's an apple," because she learns how to recognize and what the difference between bananas and apple is. Okay, so next slide, please. With the RFID, we wanted to do the same, but at this time, instead of looking for bananas and apples, we extracted all the information that the Impinj readers provide us, such as phase, RSSI, the timestamp, and then we put all these readings together, creating the so-called features that then go through the algorithm, the machine learning algorithm, and then they are classified as a good or a stray tag. Next slide, please. So these new reading systems where we apply RFID, instead of coming out with sliding doors, moving mechanical parts, and trying to contain the reading volume as much as possible, we basically read everything that is in the field of view of the reader. And then it's up to the algorithm to filter out the stray reads and also correctly assigning tags to the proper item, even when they are in bulk and in motion, because in some systems, we can imagine that I don't have only one stack of textile in the field of view of the antennas. I might have many of them, but still the system is able to say, okay, this list of EPCs belong to this one, and these others, other EPCs belongs to that one. So this is where the machine learning apply where the powerful machine learning applies and give us a very good result without ending up in mechanical solutions or manual algorithms and manual thresholds set on the reader. Next slide, please. So like in any machine learning application, no matter if it is RFID or image recognition or whatever, the greater the amount of data is, the more accurate the neural network will become. And the biggest advantage of this is that even if a laundry has a completely different environment or use case, the system can be retrained, so the system can learn on a new set of data how to recognize stray reads and then properly assign tags. So without having to reprogram the whole algorithm, redesign a new algorithm, the system can just be fed with a new set of data, learn, and then start running and doing classification. Next slide, please. Because everything happens in software, or most of the things happen in software, the system allows us to have a much lower amount of hardware components, so no mechanical moving parts. We basically need antennas, the reader, and then the software. And if we find a way to improve the system where we get a better classifier by using a bigger data set for training, we can just push the update to CloudBurst and automatically, without being on site and changing anything, we can make the system more accurate. This being said, I'm not saying that the hardware is not important anymore, because the RFID cannot do the magic. I mean, if I don't read a tag, there's no way the machine learning come up with the EPC. And so it is extremely important that the reader, thanks to the sensitivity and the ability to read tags multiple times, give us the biggest amount of data so that the algorithm can better look at the properties and these patterns and then take a decision whether it is a stray read or not. So the hardware is still playing a big and important role on this.
Thank you, Andrea. And so you mentioned that hardware plays a really important role in providing good quality data for RFID. So Jonathan, so R700, we think obviously it's a superior reader, a great product. So can you give us an overview of how R700 provide superior readability?
Sure. So what I'm showing here is a plot that shows the various RF modes or reader modes that we can operate the R700 in, specifically when it's configured for the EU in the high band, which is the 915 to 921 megahertz band. And what we're seeing here is that in the fastest mode, if the R700 sees several tags in the field of view, so that's meaning that there's something like a laundry item that has a tag embedded or attached to it near that antenna, we can achieve a read rate of around 900 tags per second. So that's rereading the same tags multiple times, feeding that data to the algorithm that Datamars has written. Additionally, as we go to the right on the chart, you can see the sensitivity gets lower and lower, and that's actually maybe a little counterintuitive, but that is the ability for the reader to deal with interference from other readers or reflections in the environment or a tag that's deloaded. So even by going to this hybrid mode, which increases or lowers the receive sensitivity, makes the reader operate in a way such that it's easier to read hard to read tags, we're still able to achieve 550 tag reads per second. So we just wanted to put this slide here to showcase that the ability for the reader to have really good receive sensitivity is what's allowing Datamars to build on top of this excellent RFID algorithm to make it easier to deploy these applications.
Great, Jonathan, thank you. And so now you've heard the importance of having superior quality tags, readers, and why they're important to deployment. So environment is also very important. So Julian, can you talk a little bit about what's the best environment to deploy RFID?
Yes, sure. So the first system, I mean, there are many systems where we could apply this technology, but the first system on which we apply it, we can see it in the next slide. This is this open tunnel. So in the laundry, this open tunnel is placed on the clean side, meaning that the textile have been washed and folded, and in this use case, they are stacked on this pile of 5 to 25 to 30 pieces, so containing each 30 transponder, let's say, and they go through a conveyor. The role of the tunnel is to read each tag and to assign correctly each tag to the correct stack of textile. So on this conveyor, you have to imagine 2, 3, 4 pile of textile that are moving close to each other, pretty close at a very, I would say, high speed. And that's a challenging environment because the stack are close to the other. So potentially reading one stack of textile without reading the other is difficult. And you want to do that while the conveyor is moving. We have seen that for this type of application, we are getting excellent results with RFID. So the kind of result that we are not getting using normal, let's say, threshold-based solution. Talking about numbers, we have listed a few numbers in the next slide. So in a real laundry environment, we got over 99.9% of accuracy using a machine learning classifier. I mean, for people who are used to UHF reading performance, this 99.9 is really an impressive number. And to give you an idea of the challenge we are facing here for this sort of application, we have copy-pasted below a few lines of the log file we are getting from this tunnel. Each line corresponds to a stack of textile being read. And in the first red column, you see the number of tags that the algorithm, that the system has classified as a good tag. So in average here, it's 25, which correspond at the expected size of the stack. And on the other column, we have the number of stray reads that were filtered out by the algorithm. And this number of stray read varies from 50 to 56, 57, meaning that in average for each good tag that is being read, we are reading twice the amount of stray reads. And these stray reads are coming from the outside environment, but also from the adjacent stack of textile. And again, getting this same of results, so such an accuracy, having to filter this many stray reads, doing that by playing on the reader power and the reader sensitivity would be best case extremely unreliable, worst case would not work at all. So for this kind of application, really the machine learning approach is giving excellent results. That doesn't mean that's the secret solution and the miracle solution for everything. In the next slide, we see that some other kind of application are not suited. And here, so what we see on the picture is a typical laundry trolley. In this trolley, we can put up to 1,000. In some cases, when you have small piece of textile like napkin, you can have up to 2,000 napkins and then 2,000 transponder in a single trolley. If you want to read such an amount of transponder, right now it will take you 3 to 6 seconds. Considering that machine learning rely on the fact that you need multiple reading at the same time. If you want to read each time 2 or 3 times in order to find out the reading pattern and to classify them, it's going to take you 15, 20 seconds. This amount of time is clearly not compatible with the activity you have in the laundry. You cannot stop a trolley for so long, or you cannot wait for a reading for so long. So in these specific cases, we still believe approach like the cabinet, for example, is more performing than machine learning, at least in the way we are currently using it. Yeah, next slide.
Okay, thank you, Julian. It's fascinating. So now you're probably wondering, so how can RFID be deployed? So Andrea, would you like to talk about that?
Yeah. So at the beginning, Julian mentioned that our solution includes a software layer, which is called CloudBurst. And the RFID algorithms are actually implemented into CloudBurst. So CloudBurst runs directly on the reader, meaning that all the processing of these machine learning algorithms takes place directly on the reader without requiring any additional computer or server where the algorithm should run on. CloudBurst basically has two main purposes. On one side, it manages reading systems like the tunnel, for example, and pre-configure all the parameters so that our customers, they don't need to suddenly become RFID experts knowing how, okay, this specific configuration or parameter needs to be set in that way. But thanks to a set of pre-configured reading modes or operating modes, that's how we call them, the reading system become plug and play. And that's also in CloudBurst where we can implement our algorithms. And on the other side, we provide a full set of data protocols, interfaces, and data formats so that the systems are compatible with basically any laundry software or ERP. And also this means that when implementing an RFID system, there's no need for software development, but the laundry is ready to get clean and accurate data ready for their business without having to care about how the RFID technology works.
Okay, and so now I think there's actually a pretty cool demo video to show how RFID is deployed. If we can pull up the video, that'd be great. Okay, great. Thank you for that video. What a cool video. So Andrea, do you want to explain what the audience just saw?
Yeah. So, well, this is a demo we created in our lab, but it's highly representative of what could happen actually at the laundry side. And basically, this is also how we started developing the system. So the kind of environment we wanted to test, basically. So at the beginning, we shown you the environment. So we have a static stack of textiles that is placed right there at the entrance of the tunnel. We have a swinging bag full of textiles that is swinging back and forth towards the entrance and the exit. We have the laundry cart full again of textiles that is moving parallel to the conveyor belt and more or less at the same speed. And then we have a couple of stacks made out of 25 pillowcases going through the tunnel, and those two actually are the wanted items to be recognized and outputted or sent to the laundry software layer. On the timeline, we see in pink, the pink bar at the bottom is basically showing you that the stray reads coming from the static stack of textiles are always there. So we always read those 4 tags out of that stack continuously. Then we have the yellow dashes that are the stray reads coming from the swinging bag. In green and blue, we have the 2 stacks of 25 pillowcases, and then in purple we have the stray reads coming from the laundry carts. Now, as you can see, if we look at the place where well, we are more or less in the middle of the green bar and at the beginning of the blue bar, we see that the system can actually see the 25 tags from the first stack of pillowcases, can already see the tags from the second stack of pillowcases. We can get 5 tags from the swinging bag, 4 tags from the static stack of textiles, and then we pick up a few stray reads from the moving cart. So, and this is happening right in the middle of the tunnel, while the first stack of textiles is right in front of the antennas. So now, if you imagine that we have no way to filter those stray reads without having something that is more powerful than just a threshold or a trigger, because the middle of the stack, well, when the stack is in the middle of the system, should be in theory the best moment in time where we are sure that you can read all the tags. But as you can see, because the tunnel is open and there is no shielding in place, we also pick up many stray reads. And despite this, the system is able to recognize them and filter them out. And also, because the 2 bars, the green one and the blue one, they overlap for a certain amount of time, we are also, that means that while we read the first tag, we also read the second one, but still the system is able to identify them and correctly assign the 25 plus 25 tags to the proper stack. So I hope I gave you an idea of what the system sees in terms of amount of tags and stray reads, and also the ability of the system to discard and filter them out, even though these stray reads pop up right in the middle when you don't want them, basically.
Thank you, Andrea. We actually have a live question from one of the audience members regarding the video. So if you could pop back on and help answer this question. So an audience member is asking, when are the wanted tags transmitted in this scenario seen in the video, after the transfer or during the transfer?
The data is outputted when the stack reaches a certain point outside of the tunnel. So basically, to give you a rough idea, when you see the stack of textiles outside of the mechanical the tunnel, basically, the mechanical structure of the tunnel, that's where we print out the data. So we don't need to wait too long.
Okay, well, thank you so much, and keep those questions coming. Okay, so next slide, please. Andrea, you mentioned, and the Datamars team talked about the CloudBURST software, and they have a special prize for attendees of this webinar. So the first 5 people who email Datamars will receive a free CloudBURST license with a value of over $1,200. So the first 5 people to email textile.marketing@datamars.com will receive a free license. So thank you, Datamars, for providing that. And we are near the end of our webinar, and there's another couple of live questions that came in. So, and I'm hoping the panelists can help answer these. So it looks like, so first question, it looks like the tunnel structure is made of metal. Does it act as a shielding? Julian, do you want to take this one?
Yes, sure. Yeah, that's a good question, and that's worth noticing. It's true. It's made of metal, and as you can see, you have also metal below. And as we were mentioning, I mean, it's important to read the tag as many times as possible, and basically to get rid of the tag that would be read continuously, because if you have tags around that are being read hundreds of times, it will basically take out some bandwidth for the machine learning algorithm to do its job. And what we are trying to do with this shielding is basically to limit the number of tags that would be standing still around the tunnel, and that would basically take out some bandwidth and take out the possibility to read the tag, because as we said, we need to read the moving tags as many times as possible. So it's not a shielding in the sense that we don't want to get out any stray read, but we want to leave more, let's say, space for the reader to get this reading, so that the algorithm can analyze them.
Thank you, Julian. Great answer. Okay, so last question, I believe, unless I see more live questions come through. So how quick is the machine learning algorithm in classifying each tag? Andrea, do you want to take this one?
Yeah, sure. Well, basically, despite the fact that the algorithm runs on the reader, it's pretty fast in doing all the calculations, and the results come out basically immediately. So there's no need to wait to let the system do the job, and there's no need. More importantly, there's no need to stop the flow, so to let the system do the calculation, but it works basically in real time.
Okay, well, thank you. And we have another question that just came in. Again, keep those questions coming. I am going to take a look at this question. Let's see, to improve accuracy, do you have data upfront about what you are expecting to read? Andrea, what do you think?
Well, I'm not sure what data upfront means, but if that means knowing some information about the bundles in advance, like the size or the expected amount of tags within each bundle, the answer is no. The system does not know anything about the items, these tags that are coming in. I hope I answered this question and I intended it right.
Thank you, Andrea. I know you tried your best. And, you know, to the audience members, if you have more questions, you can always ask them, and we can always try to answer your questions after the event as well. And the session is being recorded, and we will share the recording with all of you as well. So we moved along quite quickly, and I want to thank all the panelists today, and of course our audience. Thank you so much for joining us. Please note that we do have a very short survey at the end of this webinar, and the first 10 people to complete the survey will win a prize. We have lots of prizes for this webinar, and these surveys will help us improve future events like this one. And so now I'd like to bring all the panelists back on just to say a quick goodbye. Okay, and if can we remove the slide, please? So we just see the panelists. All right. Well, thank you guys so much. Thank you for asking all the great questions, and thank you to our panelists today. I thought this was a great webinar, and we're at the end. So have a great one.
Thank you, everybody.
Thank you, everybody.
Bye. Thank you.